So in this video, what I'm going to show you is my favorite color, 400 nanometers. That's a dark violet color. How I'm going to figure out how much energy there is per photon that's emitted to create that 400 nanometers that you see, that dark purple. And then I'm going to show you how to convert that into joules per mole. Okay, so if I have 400 nanometers, the first thing I need to do, because I need to be in meters, I've got to convert it to meters. So to do that, I recognize that there are 10 to the 9th nanometers in a meter. So I'm going to take that 400 nanometers and I'm going to divide it by 10 to the 9th. And so what I end up getting is 4.00 times 10 to the negative 7th. You should be able to do that pretty much in your head or just plug it into the calculator. You should not have to set up a conversion. So that's 4.00 times 10 to the negative 7th meters. And now I'm going to use my c, which is speed of light, equals lambda, which is wavelength times frequency formula. Okay? And so I'm going to take my speed of light and divide that by my wavelength in order to get frequency. And so what I end up getting for frequency is 7.495 times 10 to the 14th seconds to the negative 1, or just hertz. Now notice I don't round this. I'm not going to round this until the very end. Okay? The next thing I need to do is to figure out the energy. Well, energy equals Planck's constant, which is 6.626 times 10 to the negative 34th, times my frequency. And so I'm going to plug that in. I'm going to multiply Planck's constant by my frequency, and what I get is 4.97 times 10 to the negative 19th joules. Well, what's implied here, not actually stated but implied, is that is the amount of energy that is released. Remember, your electron is jumping from a high energy, excited state back down to a low energy, ground state. That is joules per photon of energy. Well, the question is, what if I want to know how many joules per mole are released? So instead of one single photon, something that's a little bit more reasonable, because you're not just looking at one photon, but rather a mole, a large quantity of photons. Well, since I have joule per photon, what I can do is I can convert from joules per photon into joules per mole. So I'm going to put photons up top to cancel them out, and I'm going to put moles on the bottom. And so what I know is that there are 6.022 times 10 to the 23rd photons, or just 6.02 is fine as well, times 10 to the 23rd photons per 1 mole. And so now when I just multiply that across, now I have 2.99 times 10 to the 5th joules per mole, and that's it. So you went from nanometers into meters. You were able to figure out frequency, then energy, so joules per photon, and then into joules per mole. And so all the questions in your lab will be some sort of variation of all of these steps.